birthday. It's your birthday. Children, I put the fun in functions. JK. God does. No, just kidding. Functions are fun, okay? They are. I know, you're overwhelmed right now. I can see it already. You're like, what the heck is she doing? We got a lot to do today. But it's going to be fun. And you're going to be like, wow, I didn't realize all this was just in the first section of functions, okay? So we're going to do a little bit of definitions. I'm going to show you a couple examples of what will be in homework. You'll see it's not that bad. We'll do some more examples about notations, really about notation, because we're really heavy in pre-calculus with notation. If you can understand function notation, calculus is going to be so easy for you. I always say the hardest thing about calculus is algebra. That's it. Kids don't know algebra. It's super easy. If you know this notation, you'll be great. So let's just write a couple of definitions real quick. Let me tell you what a relation is. You've heard of this before, but I want to use this math vocabulary because you're going to see it a lot on ACTs and SATs too. A relation is a set of ordered pairs. A set of ordered pairs. So what they do is they take a bunch of XY coordinates, like 1, 2, 2, 4, 3, 6, 3, 0. And they write them out, and then they put this little squiggle brackets next to it, because squiggle brackets means that's a set. Ta-da! There's your relation. It's a set of ordered pairs. Just putting all the ordered pairs together, okay? Now, from that set, we have special names for the x's and the y's, and I know that this is familiar, so we're going to go through it again. No worries, okay? The x's are called the domain. Do you remember hearing that, right? So the domain are your input values, also known as your x's, also known as your independent variable. Those are your independent variables. Okay? So your domain right here would be everything, and you put it in a little set notation, and you just write the x's. So I would write 1, 2. I wouldn't write 2 3s because that would be redundant. So I just write 3. 1, 2, and 3, those are my domain. That's my x's. Anybody know what the y's are called? Range. Easy, you've done this. Those are your output values. Your y's, they are dependent. And again, you put them in squiggle bracket, and then you would just list out all the y's. And you're supposed to put them in order, but if you don't, I'm not mad at you, okay? So like if you were like, I'm just going to write 2, 4, 6, 0, that's fine. I like order, so I'm going to write 0, 2, 4, 6. I'm not mad at you, but just so you know, put them in order, okay? So a relation is just a set of ordered pairs. The domain is all the x's. The range is all the y's. That's it. That's all it is, okay? Now from that, we have what's called then a function, okay, which is another type of rule. So a function or functions, by definition, are a relation. Oh, there's that word again. That set of ordered pairs. But here's the new thing. Where each input value leads to exactly one output value. Oh, you can't see it down there. Sorry, guys. A relation where each input value leads to exactly one output value. So now what we do is we take a y and we call it f of x. Okay? And that's the notation now we use to be a function. Okay? And what happens is then this right here, this x, is my input value. That's my domain. And what I get out here is my output values. Okay? So it's like a machine. But even more specifically, it can only have exactly one output value. So what does that mean? Well, you learn these three things with Mr. Belk, maybe 2 of them. But there are 3 ways to determine a function. 3 ways to determine a function. And we'll go through the 3 ways real quick because I know you know them. I know you remember them, okay? Have you heard of the first way? The first way is, have you heard of the phrase x's can't repeat? You've heard that, right? Didn't he say that before? Your x's can't repeat. Your x's can't repeat, right? Okay, so like going up here to this relation, are my x's repeating? Oh, they are. So is this a function then? No, it's not. It's just a relation. The x's are repeating. So number 1, your x's can't repeat. If it repeats, it's not a function. No, no, no. Your x's can't repeat. You know this, okay? Number 2, you've heard of this one. Have you heard of the vertical line test? The vertical line. Yeah, you got to pass that vertical line test. What does that mean? That means if you draw a vertical line, you can't hit the graph twice. Because then guess what? Your x's are repeating. Okay? So it's got to pass the vertical line test. Number 3 is probably going to be new for you, okay? And it deals with an equation. If you solve the equation for y, it should be with only one output. And I'm going to do an example of that for you so you can understand like what the heck does she mean by that. I'm going to show it to you. But I want to give you like 3 examples down here of what they're going to do on homework. That's what I'm saying. Homework sounds like a lot tonight, but it's really not. They're going to give you a table. Pull this down a bit. They're going to give you a table, and they're going to have like 1, 7, 2, 3, -3, 4, -5, 7. Or they might give you a graph. Let's draw some pretty graphs. Ooh, there we go. Let's do another one. Ooh. You got to make sounds while you graph, right? Or they might give you an equation. Okay? Your job, and again, this is part of pre-calculus. This is the hard part, is you need to be able to read a table, a graph, an equation, and know what we're talking about, knowing if it's a function or not, knowing how to solve it and whatnot. Okay? So, table number 1, is this a function? Yeah, why? Are the x's repeating? Can the y's repeat? Yes, it didn't say anything about y's. X's aren't repeating. We're good. We are a function. I'm just going to put F. Function. Yay. We win. All right. Now we're looking at graphs. Well, now I'm not going to see if the x's are repeating. I'm kind of going to do the vertical line test, right? Because that's easier. Now, this looks like it's going up straight, but just so you know, it's curving. It's ever so slightly curving like this. So when you do draw vertical lines, it's only hitting once, only hitting once, only hitting once. Oh yeah, that one is a function. That's good. That passes the vertical line test. That's good. Is this one passing the vertical line test? It hits twice when you make a vertical line. So not a function. See, easy. This is what homework is tonight, okay? Look at the relation. Are the x's repeating? Function, not a function. All right, can you do a vertical line test? Function, not a function. This one is equation solving. When they give you an equation, solve it for y, okay? Solve it for y. If you don't know what the graph looks like, then plug it in your calculator, right? You could do that tonight for homework. Well, Monday night for homework, you do that. Plug it in your calculator, see what it looks like. But this one is tricky, and I'll show you why, okay? So if I were to solve this for y, what am I going to do with Mr. X squared? Let's bring it to the other side with subtraction, right? So y squared equals 1 minus x squared. I subtracted over. You should know that, okay? How do you get y by itself now if it's being squared? You should know this. How do you undo a squared? Square root. Okay, so square root, square root. The square root and the squared on the y will cancel. But this is something that a lot of students don't remember, and it's something big and huge. When you take a square root, you have to put a certain symbol in front of the square root sign. Anybody know what that sign is? Plus or minus. Only with a square root or a fourth root or a sixth root or any even power. You don't do that with a cube root. Like if you were taking the cube root of both sides, you don't put plus or minus. If you're taking a fifth root, you don't put plus or minus. Only with square roots or fourth roots or any even powers. Now, what does that mean? Well, see this right here? That now means you have 2 outputs. that your x's are repeating. If you put an x in here, if you put like 4, you would have 2 different y values now. So this is not a function. And again, for those who don't know, you should know what this picture looks like. If you don't know what x squared plus y squared is, it's actually a circle. Anything that says x squared and y squared plus y squared, it makes a circle. And this is your radius. It has a radius of, well, this is your radius squared, so it has a radius of 1. And so it looks like that. Would that pass the vertical line test? No. Boom, boom. So that's why if you see a plus or minus, if you're solving and it's an even power like that, it doesn't do that. That was easy, wasn't it? It's not hard. You've done this before. All right, well, let's go to a little bit more. Let's do a couple more things and we'll be good to go. Let's evaluate functions. This is the next thing you'll do on that night's homework, evaluate functions. They're going to give you a function. So f of x equals x squared plus 3x, well, minus 4. And then they're going to give you different things. They're going to say f of 2, f of a plus h. Ooh, let's do this one. F of a plus h minus f of a all over h. Oh, just wait. Just wait. This is exciting stuff. All right, so what am I asking you to do here? You know this. You know this. What does this mean? What do I do with 2? F of 2. What am I going to do with 2? You just plug it in, right? Isn't that what you just do? Everywhere you see an x, this is your input, so what are you going to plug in? 2. So you're going to do 2 squared plus 3 times 2 minus 4. And you're going to clean it up for me. You're going to tell me what the answer is. Well, 2 squared is 4. 4 plus 6 is 10. 10 minus 4 is 6. There's your answer. The f of 2 is 6. The output value when I input a 2 is 6. That's what that's saying. Wait, it gets even easier. Are you ready? What would f of a be then? What would I do? You just put an a. So everywhere you see an x, you put a. So what does that mean? So you have a squared plus 3a minus 4. Well, what do I do, Mrs. said? Well, you leave it alone. That's the answer. You just plugged in a. It's done. It's just that easy. It's just that easy. If it was f of c, c squared plus 3c minus 4, you just plug a c in. Easy peasy. Okay? What do I do here then? What if it's a plus h? You plug it in, but now it's a binomial. Okay, this is a monomial. This is a binomial. So we're going to have to do something extra here. You'll see. But I'm still going to start it off the same way. Everywhere I see an x, I'm going to put a plus h squared plus 3 times a plus h minus 4. Okay? That's a good start, but you need to clean this up. So what you have to clean this up is you're going to have to clean this up. Now listen to me. This gets on my nerves. Another thing gets on my nerves. I don't have a lot of nerves, y'all. Don't do this. A lot of students think that a plus h squared is just, oh, isn't it just a squared plus h squared? No. Negative. I'll put it here on the side. A plus h squared means take this binomial and multiply it by itself, which means it becomes a trinomial. You have to FOIL it. You have to FOIL it when you square binomials. What do you mean? A times a is a squared. A times h is ah. H times a is another ah. H times h is a squared. So you have a squared plus 2ah plus h squared. You have a trinomial. So this right here, this little thing right here, is a squared plus 2ah plus h squared. Oh. Am I done? No. Could I clean this up right here? What does that become? 3a plus 3h. And then what else do I got? Minus 4. Is there anything else I can combine? No. You're done. That's done. So that's what I'm looking for. If you put a binomial in here and had to square it, you better make sure you FOIL it. You better make sure you FOIL it. Okay? And then you got to clean this all up. All right, are you ready for this one? This is going to blow your mind. You're about to do calculus. I'm not even lying to you. You ask your siblings that have had me. This right here is a very famous formula in calculus that we will learn again at the end of the year. But I want to see if you know and understand what it's asking you. It's not asking you anything difficult. Are you ready? F of a plus h minus f of a all over h. Do you know what this is? What is this, though? Isn't this the problem we just did up here? Isn't that what that is? So couldn't I just replace this with that? Yes. You just did that right there. Look, we just did it. Okay, so I'm going to write a squared plus 2ah plus h squared plus 3a plus 3h minus 4. Okay, that's what that is. Okay, but wait, it gets better. Then what's f of a? Isn't that what I just did right here? Didn't I just do that right there? All right, but then what do I do with a minus that? What do I have to do then? Change all them signs, right? Wouldn't that be the easiest thing? That says change all the signs of f of a. Okay, so I'm going to go minus a squared minus 3a plus 4. And then I'm going to put the whole thing, it tells me, over h. And I'm going to clean it up. You ready? This is cool. What goes away? Goodbye a squareds. Goodbye 3a and minus 3a. And goodbye minus 4 and a plus 4. But wait, there's even more. If I'm dividing by h and what's left, everything has an h, can I get rid of an h then? Yeah, anything on top, anything, as long as everything's got it. So what's my final answer? 2a plus h plus what? Guys, you just did, this is called the difference quotient. This is calculus. This is actually what you learn is called derivative. The entire calculus 1 is called a derivative. There's easier ways to do a derivative, but you just did what's called a derivative. You just did calculus. You're welcome. Brilliant. You go home tonight, you tell your parents how brilliant you are. You did calculus, you didn't even know. You are calculate, my friends. Proud of you. That is crazy. If you understood that, then you're going to be fine with function notation. That's all it is. It's plugging in this, and then it's plugging in this, and then it's subtracting and it's putting over h and it's reducing. It's literally the hardest part of calculus. I tell the kids all the time. It's just simple math. Okay. All right. Your brain is breaking. I know, but don't worry. We got more. We're almost done. We got more. We're going to solve functions, and then we're going to just do some evaluating from a table. We're almost done. Like, that wasn't it? No. All right. H of p equals p squared plus 2p. Find hp equals 3. And then we'll do another one. G of m square root of m minus 4. Find g of m equals 2. Okay. Again, man, if you just know the notation, this isn't going to be hard for you. It's not. This is not going to be hard if you just know notation, okay? So they've given you a function. They've even told you what to do. And then over here they said, okay, well, find what HP equal to 3 is, okay? This is, notice it's different. Up here, when the number was next to it, that was your X, right? Well, what did I give you now? I told you what it equals, didn't I? Are you supposed to take this 3 and plug it in for 2? Is that what that's saying? No. If I wanted you to plug the 3 in, wouldn't I have put it here? So this is actually what it equals. It's the y. So what am I going to do? You're going to set 3 equal to that. Isn't that what I'm going to do? Okay? So p squared plus 2p equals 3. Now, again, this is why I told you this is stuff I can't teach you. You should already know how to solve this. And if you don't, when you're dealing with squares and things, you usually set them equal to 0. So I'm just going to go p squared plus 2p minus 3 equals 0. You set everything equal to 0. And then this should look familiar to you. This is a trinomial. Trinomials we factor. Can we factor that? Can you think of two numbers that make a negative 3 and add to 2? 3 and 1, right? P and P. So then what are my two answers for P? -3 and +1. You just solved for P. You just found it. You used notation. This is the backwards of what we were just doing. This is why calculus, we always do it one way and then we do it another backwards way. Okay? How neat. All right, then can you do this one real quick? Same idea, right? You're not going to plug in a 2. You're going to set it equal to a 2. You're not going to plug in a 2. You're going to set it equal to a 2. See if you can solve it, and then I'll solve it for you real quick. Did you at least start off like that? Square root of n minus 4. I'm just doing what you just did before, Miss Seti. Yeah, good. Good. Do what I do. Okay? How do you undo a square root? Square both sides, right? The square root and the square cancel. You got m minus 4 equals, what is 2 squared? 4. You don't have to put a plus or minus on this one because you didn't take a square root. You squared. Okay? Know the difference. And then add 4 over. What are you going to get? M equals what? 8. Done. Muy bien. See the difference? Do you see the difference? Please tell me you can see the difference, because if it's got this right here, that's your x, you plug it in. If it says, no, I equal 3, then you set it equal to. Done. It's easy. Notation. Super important. Last two things. You have got to evaluate and solve from a table and a graph. Evaluate, yeah, wow, and solve. And you're going to do it from a table and a graph. So the first one I'll do from a table. Find the g of 3, and B, solve g of n equals 6. And then here's your little table. 1, 8, 2, 6, 6. Let's just do a couple here, and then let's do a graph. Find f of 2, and then we're done. And this is what homework will be like. I mean, again, hardest part of homework is just, you can't see it? Thank you. I'll give you a minute. Sorry about that. Thanks, Josh. This is supposed to be a 2. Sorry, I wrote 3 and I didn't mean it. All right, you're doing great. You're doing great. This literally is like so fundamental. And if you can understand this, this is going to be awesome. Fire, okay? Let's look at the table thing, okay? This right here on the inside is your what? That's your input, right? So your x, well, in this case, I guess it would be n, right? Isn't this your n? So on the table, I'm going to go to the n, go to 2. And I'm asking you then, okay, well, what's the output? You would tell me what then? Done. There's the answer. That's it. I actually, before I should have left it. If I had g of 3, what would you have said? What would you have said? Is there a 3 on the input? You know what you would have said? Undefined. It's not there. It's something like that. None or whatever. I don't care. You're supposed to say undefined, but that's cool. All right, well, now what's this way asking? What's this way asking? What the input is if I have a 6 for my y, or, you know, for my g or whatever. So now I'm looking at the y part. This is the y part, you know, this is your x part, if you think of it like x and y's. Well, I have a 6 here, yes, but don't I have another 6 here? So then what would be my 2 answers? 2 and 4. Done. Good job, guys. Yeah, that's reading a table right there. You got to go. You need to know, are they giving me an X and do I give them a Y? Or are they giving me a Y and I give them the X that coordinates, that corresponds to it? That's it. That's literally how homework is. Did they give me an X? Okay, I give them a Y. Did they give me a Y? Okay, I give them an X. Same idea is here. Don't freak out. It's the same idea. Are they giving you an X or are they giving you a Y? What are they giving you here? An input in X, so you're going to give them a Y. So you're going to go to 2 on the 1, 2, here it is, on the X, yes? And you're going to go up to the graph and give them the Y. What is the Y value right there? 1. That's the answer. It's the same thing, okay? Give me the X, give you X, go up, find the Y. But now I'm doing this backwards now. This is weird. This is the what? Y. So I go on the, watch, I go to the Y-axis, 1, 2, 3, 4, and you tell me which points have 4. Well, wouldn't there be 2 of them? What's this one? -1, and what's this one? 3, and that's your answer. Do you see the difference? Fire. If you can understand this, this is all it is. Guys, you did calculus today. You learned how to find and determine if you are a function, and then you learned how to evaluate, you learned how to solve, and you read it off of a table and a graph. Very good, very important fundamental stuff. And if you did, I mean, just go home. I did calculus today, Mom and Dad. I'm brilliant, okay? What are you going to do this weekend? Again, I'll tell you, I was telling the other class, I have a master's degree in